What if the sun dimmed by half overnight? Picture this. You wake up tomorrow morning, stumble to your kitchen window with that first cup of coffee in hand, and something feels wrong. The light streaming through your blinds isn't quite right. It's not cloudy outside. The sky is clear, but everything looks dimmer, like someone turned down the brightness setting on reality itself. You step outside, and the sun is there, exactly where it should be, but it's only half as bright as it was yesterday. Not covered by clouds, not partially eclipsed, just dimmed. Like a cosmic dimmer switch was turned down by 50% overnight. Your neighbors are standing in their driveways, phones out, looking up at the sky with the same bewildered expression you probably have. Social media is exploding. News anchors are struggling to explain what they can't understand themselves. Scientists are scrambling for answers. And somewhere in the back of your mind, a terrifying question starts to form. What does this mean for us? For our planet? For our future? Welcome to Javis Heist, where we dive deep into the mysteries that keep us wondering long after the story ends. I'm your host, and today we're exploring one of the most chilling scenarios that scientists and astronomers have quietly discussed in academic circles. What would actually happen if our sun's output suddenly decreased by half? Now, before you think this is pure science fiction, let me tell you something that might surprise you. Stars can and do dim. It's happened before, and it's happening right now, somewhere in our galaxy. The question isn't whether it's possible, it's what would happen if it occurred to our Sunday. To understand why this scenario is so terrifying, we need to start with something most of us take completely for granted: the remarkable consistency of our Sunday. For over 4.5 billion years, our star has been what scientists call remarkably stable. Think about that for a moment. Every sunrise you've ever witnessed, every warm summer day, every ray of light that's ever helped a plant grow, all of it powered by a star that has maintained roughly the same energy output for longer than complex life has existed on Earth. The sun produces about 3.8 times 10 to the power of 26 watts of power every single second. To put that in perspective, that's more energy than humanity has used in our entire existence, produced every single second. This energy travels 93 million miles through the vacuum of space, and just the tiny fraction that reaches Earth, about 1/1000th of the sun's total output, powers virtually everything we see around us. The wind in the trees? That's solar energy, creating temperature differences in the atmosphere. The rain that fills our rivers? Solar energy evaporating water from the oceans. The coal and oil that powered our industrial revolution? Ancient solar energy, stored in plants and organisms millions of years ago. Even our food chains start with plants converting sunlight into chemical energy. We live in what scientists call the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist on our planet's surface. Earth receives just enough solar energy to maintain an average global temperature of about 59 degrees Fahrenheit. This isn't an accident. It's the result of a delicate balance that has allowed life to flourish for billions of years. But what happens when that balance is suddenly disrupted? Here's where our scenario moves from theoretical to genuinely unsettling. Stars do dim. In fact, astronomers have observed numerous examples of stars experiencing dramatic changes in brightness over relatively short periods of time. Take Betelgeuse, one of the most famous stars in our night sky. In late 2019 and early 2020, this red supergiant star dimmed by more than 35% over just a few months. Astronomers watched in fascination and, I'll admit, a bit of concern as one of the brightest stars visible to the naked eye became noticeably dimmer. The cause? Likely a massive cloud of dust ejected from the star's surface, blocking some of its light from reaching us. But Betelgeuse isn't alone. There's a class of stars called variable stars that regularly change in brightness. Some pulse like cosmic heartbeats, growing brighter and dimmer in predictable cycles. Others experience sudden, dramatic changes that can last for years or even decades. Then there are the truly mysterious cases stars that have dimmed by significant amounts for reasons scientists still can't fully explain. KIC 8462852, nicknamed Tabby's star, has experienced irregular dimming events that have puzzled astronomers since its discovery. Some theories suggest massive dust clouds, others propose swarms of comets, and yes, some have even suggested the possibility of artificial structures built by an advanced civilization. The point is, stellar dimming is not just theoretical. It's happening out there, right now, to stars across our galaxy. The question that keeps astronomers awake at night is, could it happen to our Sun? Our Sun is classified as a main sequence star, specifically a G-type star. These stars are generally considered stable, but stable is a relative term in astronomy. Even our Sun experiences small variations in output about 0.1% over an 11-year cycle. These tiny changes are enough to influence weather patterns on Earth and have been linked to historical climate variations. But what we're talking about isn't a small variation. We're talking about a sudden 50% reduction in solar output. To understand what this would mean, we need to dive into the mechanics of our planet's energy balance. Let's walk through this scenario, hour by hour, because the timeline matters. Imagine you're one of the first people to notice. Maybe you're an early riser, someone who pays attention to the quality of light. You step outside for your morning jog, and something feels off. Hour 1. The first thing you'd notice is the light itself. Everything would look like it's bathed in the light of late evening, even at noon. Shadows would be softer, colors would appear muted. The sun would still be visible. It's not like it's been blocked or covered. It's just producing half the energy it did yesterday. Hours 2 to 6, social media explodes. Number dim sun starts trending worldwide. Confused posts flood Facebook, Twitter, Instagram. Is it just me, or does the sun look weird today? Scientists around the world are receiving frantic calls from observatories and universities. Emergency meetings are being called at NASA, NOAA, and space agencies across the globe. Hour 612. The scientific community begins to mobilize. Solar observatories that monitor our Sun 247 confirm what millions of people are seeing with their naked eyes. The Sun's luminosity has decreased by approximately 50%. There's no massive solar storm, no coronal mass ejection, no visible change to the Sun's surface. It's simply producing half the energy it was producing yesterday. But here's what most people don't realize in those first 12 hours. The real consequences haven't even started yet. Hours 1, 2, 2, 4. This is when the first measurable effects begin to manifest. Earth's surface temperature starts to drop. Not dramatically at first, maybe a degree or 2 Fahrenheit. But it's the beginning of something much more significant. Plants, which depend on photosynthesis, begin to struggle. Photosynthesis is incredibly efficient, but it's also precisely calibrated to current light levels. A 50% reduction in solar energy means a dramatic reduction in the rate at which plants can convert carbon dioxide into oxygen and glucose. Weather patterns start to shift. The reduced solar energy means less evaporation from oceans, less energy driving wind patterns, less power behind the massive atmospheric circulation systems that regulate our planet's climate. By the end of the first day, average global temperatures have dropped by about 3 to 4 degrees Fahrenheit. That might not sound like much, but it's just the beginning. As the first week progresses, the true scope of this crisis becomes apparent. The initial shock and confusion give way to a growing understanding of what we're facing. By day 3, global temperatures have dropped by about 810 degrees Fahrenheit. In some regions, particularly those already experiencing winter, temperatures plummet below what would normally be record lows. Snow begins falling in places where it rarely snows. Frost warnings are issued for agricultural regions that haven't seen frost in decades. The psychological impact is almost as significant as the physical effects. Humans are deeply connected to sunlight not just for warmth, but for our mental health. Seasonal affective disorder affects millions of people during normal winter months when daylight is reduced. Imagine that effect, but permanent and global. By day 5, the agricultural implications become terrifyingly clear. Crops that depend on specific temperature ranges begin to fail. Photosynthesis rates have dropped dramatically across all plant species. Farmers in temperate regions watch helplessly as their crops wither, not from drought or disease, but from insufficient sunlight and dropping temperatures. The economic implications are staggering. Stock markets around the world experience unprecedented volatility. Agricultural commodities futures spike as traders try to predict the impact on food production. Energy consumption soars as people try to heat their homes to compensate for the dropping temperatures. But perhaps most unsettling is the growing realization that this isn't a temporary phenomenon. There's no indication that the sun's output is returning to normal. Scientists are working around the clock to understand what's happening, but they're dealing with a situation that has no precedent in recorded human history. A month after the sun dimmed, the world has begun to transform in ways that would have been unimaginable just weeks earlier. Average global temperatures have dropped by approximately 1520 degrees Fahrenheit. Regions that once enjoyed temperate climates now experience conditions similar to their previous winter months permanently. The impact on plant life is catastrophic. Forests in temperate regions begin to die back as trees struggle to maintain photosynthesis in the reduced light. Grasslands turn brown and dormant. Agricultural regions that once fed millions can no longer sustain crop growth. But life is remarkably adaptable, and already we're seeing fascinating changes. Plants that were previously outcompeted in bright sunlight begin to thrive. Species adapted to lower light conditions, many of which evolved in forest understories, start to spread into areas where they could never survive before. The animal kingdom responds in complex ways. Many species begin to migrate toward the equator, seeking warmer temperatures. Others, particularly those adapted to colder climates, find themselves with expanding habitats. Arctic foxes, for example, might find they can survive in regions that were previously too warm for them. Human society begins to adapt as well, though not without tremendous challenges. Energy consumption has increased dramatically as people try to heat their homes and businesses. Countries with significant geothermal, nuclear, or fossil fuel resources find themselves in better positions than those dependent on solar energy or hydroelectric power, which is indirectly dependent on solar-driven weather patterns. Food production has shifted dramatically. Traditional outdoor agriculture has become largely impossible in many regions. Greenhouse farming, previously a specialized agricultural technique, becomes essential for survival. Indoor farming facilities with artificial lighting experience unprecedented demand. But here's what's truly remarkable. Humans begin to adapt their daily rhythms. With the perpetually dimmer light, the distinction between day and night becomes less pronounced. Some societies begin to adopt different sleep schedules. Night shift work becomes less disruptive when the difference between day and night lighting is reduced. Half a year after the sun dimmed, Earth has become a fundamentally different planet. Average global temperatures have stabilized at about 2530 degrees Fahrenheit below pre-dimming levels. Much of what we once considered temperate climate zones now experience conditions similar to what we used to call subarctic. The polar ice caps have begun to expand dramatically. Sea levels, which had been rising due to climate change, have started to drop as more water becomes locked in ice. Coastal cities that were once threatened by rising seas now face a different challenge: ports freezing over in regions where they never froze before. The Amazon rainforest, once called the lungs of the earth, has largely gone dormant. The massive trees that once formed a dense canopy now stand like skeletons. Their leaves fallen, photosynthesis nearly ceased. The loss of this carbon sink has complex implications for atmospheric CO2 levels, though the reduced plant respiration also means less CO2 is being released back into the atmosphere. But perhaps the most profound changes are in human society. Countries closer to the equator have become refuges for climate migrants from higher latitudes. The geopolitical implications are staggering: resource wars, mass migrations, and the collapse of agricultural economies in regions that can no longer sustain crop growth. Technology has advanced rapidly out of necessity. LED grow lights, once used primarily for indoor gardening and specialized agriculture, have become essential infrastructure. Fusion energy research has received unprecedented funding as societies realize they need power sources independent of solar energy. Geothermal energy, previously considered a niche renewable energy source, has become invaluable. Cities have begun to adapt their architecture. Buildings are designed with better insulation, communal heating systems, and integrated growing spaces. The concept of vertical farm skyscrapers dedicated to food production using artificial lighting has evolved from experimental to essential. As we've walked through this scenario, you've probably been wondering, what could actually cause the sun to dim by half so suddenly? This is where our story moves from speculative science into genuine mystery. Because the truth is, scientists don't have a complete answer. There are several theoretical possibilities, each more unsettling than the last. Theory 1: massive stellar dust ejection. Just as we saw with Betelgeuse, stars can eject massive amounts of dust and material that can block their light. However, for our sun to dim by 50%, the amount of material required would be unprecedented. Some astrophysicists have proposed that a massive coronal mass ejection could potentially carry enough dust and particles to create this effect. But the sun would have to be undergoing internal changes we don't currently understand. Theory 2: stellar magnetic field disruption. The sun's energy output is regulated by complex magnetic field interactions. Some theoretical models suggest that a massive disruption to these magnetic fields could temporarily reduce the sun's fusion rate. This could be triggered by gravitational influences from passing objects, changes in the sun's internal structure, or even influences we don't yet understand from the galactic environment. Theory 3. Interstellar interference. Our solar system is constantly moving through the galaxy, passing through different regions of space with varying densities of gas, dust, and other materials. Some astronomers have proposed that we could encounter a massive dust cloud or other interstellar phenomenon that could block or absorb a significant portion of the sun's light before it reaches Earth. Theory 4. Unknown stellar physics. Perhaps the most unsettling possibility is that there are aspects of stellar physics we simply don't understand yet. Our sun is middle-aged for a star of its type, and it's possible there are evolutionary phases or instabilities that our current models don't account for. Theory 5. External intervention. While it sounds like science fiction, some scientists have seriously considered the possibility of artificial interference with stellar output. Advanced civilizations might theoretically be capable of constructing massive structures around stars to harvest their energy, what we call Dyson spheres or Dyson swarms. The sudden construction of such a structure could theoretically reduce the amount of sunlight reaching Earth. Believe it or not, Earth has experienced dramatic reductions in sunlight before, and studying these events gives us clues about what might happen in our scenario. The most famous example is the asteroid impact that killed the dinosaurs 66 million years ago. The massive impact threw so much dust and debris into the atmosphere that sunlight was blocked for months or even years. Temperatures plummeted, photosynthesis nearly ceased, and the food chain collapsed from the bottom up. More recently, the eruption of Mount Tambora in Indonesia in 1815 ejected so much ash into the atmosphere that 1816 became known as the year without a summer. Temperatures dropped so dramatically that crops failed across North America and Europe. Snow fell in June in New England. Famine spread across multiple continents. These events show us that Earth's climate system is remarkably sensitive to changes in solar input. Even temporary reductions can have catastrophic effects that last for years or decades. But our scenario is different because it's not temporary. The sun itself has dimmed, and there's no indication it's going to return to normal. Here's what really keeps astronomers up at night. Our sun has been remarkably stable for billions of years. The geological record shows no evidence of dramatic, sudden changes in solar output during the time complex life has existed on Earth. So why would it happen now? Some scientists have proposed that we might be entering a new phase of solar evolution that we don't understand. Others suggest that external factors, perhaps related to our solar system's position in the galaxy, might be influencing the sun in ways we haven't predicted. There's also the deeply unsettling possibility that this has happened before, but the geological record doesn't preserve evidence of temporary dimming events. If the sun dimmed for a few decades or even centuries, would we necessarily see clear evidence of it millions of years later? The more you think about it, the more questions arise. Why now? Why so suddenly? And perhaps most importantly, is it reversible? One of the most fascinating aspects of this scenario is how it would accelerate human innovation and cooperation. Faced with an existential threat, humanity would likely respond with unprecedented unity and creativity. We're already seeing glimpses of this kind of rapid adaptation in response to climate change and other global challenges. The COVID-19 pandemic showed us how quickly society can mobilize when faced with a clear and present danger. In our dimmed sun scenario, we'd likely see massive investments in alternative energy sources, indoor agriculture, and climate adaptation technologies. Countries that have historically been rivals might find themselves working together to solve problems that threaten all of humanity. The development of fusion energy, which has been 20 years away for the past 50 years, would likely receive the kind of massive, coordinated funding that put humans on the moon. With solar power no longer viable and fossil fuels needed for heating, fusion might become humanity's only hope for maintaining advanced civilization. Genetic engineering of crops to survive in lower light conditions would become a priority. Scientists would work to develop plant varieties that could photosynthesize more efficiently in the dimmed sunlight, or perhaps crops that could grow entirely under artificial lighting. Architecture and urban planning would evolve rapidly. Cities might develop underground or enclosed spaces connected by heated tunnels. The concept of climate-controlled living would expand from luxury to necessity. As I've researched and thought about this scenario, I keep coming back to how it illustrates our fundamental dependence on forces completely beyond our control. We build our cities, our economies, our entire civilization on the assumption that the sun will continue to shine with the same intensity tomorrow as it did today. This assumption is so basic, so fundamental to our existence that we rarely even think about it. Yet it's an assumption that could theoretically be proven wrong at any moment. There's something both terrifying and humbling about that realization. All of human history, every war, every discovery, every love story, every tragedy has played out under the light of a star that we simply trust will continue to behave the way it always has. But the scenario also highlights something remarkable about humanity, our adaptability. Even in the face of such a catastrophic change, life would go on. People would fall in love, children would be born, art would be created, scientific discoveries would be made. Humans have survived ice ages, volcanic winters, plagues, and countless other disasters. We adapt, we innovate, we endure. There's also something oddly beautiful about imagining a world with permanently dimmed sunlight. Sunsets and sunrises would be longer, more gradual. The harsh brightness that forces us to wear sunglasses would be gone. Stars would be visible during the day. Aurora displays, caused by solar particles interacting with Earth's magnetic field, might become more visible and frequent as our eyes adapt to lower light levels. Artists would find new inspiration in this transformed world. Photographers would develop new techniques for the permanent golden hour lighting. Writers would explore themes of adaptation and resilience. Musicians might create entire genres inspired by the new acoustic properties of a world where wind patterns and atmospheric conditions have fundamentally changed. As our exploration of this scenario comes to an end, I'm left with more questions than answers, and I suspect you are too. Would humanity unite in the face of such a global crisis? Or would we fragment into competing groups, fighting over increasingly scarce resources? How long would it take for us to develop the technology needed to maintain our current population in a world with dramatically reduced solar energy? What would happen to our understanding of science and astronomy? Would this event revolutionize our knowledge of stellar physics, or would it remain a mystery that haunts us for generations? And perhaps the most haunting question of all, if this happened to our sun, what does it tell us about the sun's future? Is this a sign of aging, of instability, or of some external influence we don't understand? There's also a philosophical dimension to consider. How would such an event change our relationship with nature, with technology, with each other? Would we become more humble in the face of cosmic forces beyond our control? Or would we become more determined to develop the technology to protect ourselves from such events in the future? Some scientists have seriously proposed that advanced civilizations should develop stellar engineering capabilities, the ability to stabilize or modify stars to prevent exactly this kind of scenario. It sounds like science fiction, but then again, so did space travel and genetic engineering not too long ago. Here's what I find most intriguing about this scenario. While we've been exploring it as a thought experiment, the truth is that astronomers don't know for certain that it couldn't happen. Our understanding of stellar physics is constantly evolving, and there are still fundamental mysteries about how stars work that we haven't solved. Every few years, astronomers observe something that challenges our understanding of how stars behave. The recent dimming of Betelgeuse was just one example. There are stars out there doing things that our current theories can't fully explain. Our sun is constantly monitored by satellites and observatories around the world, but we're essentially watching a massive nuclear reactor from 93 million miles away and trying to predict its behavior based on the light it emits. There could be processes happening in the sun's core right now that we won't detect until their effects reach the surface, which could take thousands of years, given how long it takes energy to travel from the core to the surface of the Sunday. The more I learn about stellar astronomy, the more I realize how much we still don't know. We're like early explorers trying to map an entire continent from the coastline. We can see the broad outlines, but the interior remains mysterious. This scenario forces us to confront the possibility that our sun, the source of essentially all energy on Earth, might not be as stable and predictable as we assume. It's a reminder that we live in a universe that's far stranger and more complex than our daily experience suggests. Tonight, when you step outside and look up at the stars, I want you to really think about what you're seeing. Every point of light in the night sky is a sun like ours, burning nuclear fuel and radiating energy into space. Some of those stars are younger than our sun, some are older, some are more stable, others are highly variable. And somewhere out there, orbiting those distant suns, there might be planets with their own versions of life, their own civilizations, their own scientists looking up at their sky and wondering the same things we wonder about. Some of those civilizations might have experienced exactly what we've been discussing today. Their sun might have dimmed, and they might have faced the same challenges of adaptation and survival that we've explored. Others might have developed the technology to prevent such events, or to adapt to them so completely that a dimming sun would be nothing more than an inconvenience requiring some adjustments to their energy infrastructure. The universe is vast and full of possibilities we can barely imagine. Our scenario of a dimming sun is just one of countless cosmic mysteries that remind us how much we still have to learn about the universe we live in. As I wrap up this exploration, I keep coming back to the idea that the most important mysteries aren't necessarily the ones that get solved. Sometimes, the most valuable mysteries are the ones that change how we think about ourselves and our place in the universe. The scenario of a dimming sun forces us to confront our assumptions about stability, predictability, and control. It reminds us that we're passengers on a small planet orbiting a star that we don't fully understand, in a galaxy that contains billions of other stars, most of which we know almost nothing about. But it also reminds us of something remarkable about human nature: our ability to imagine, to prepare, to adapt, and to find hope even in the face of cosmic scale challenges. Whether or not the sun ever actually dims by half overnight, thinking about this scenario teaches us something valuable about resilience, about the importance of scientific understanding, and about the incredible interconnectedness of all life on Earth. It also reminds us not to take for granted the remarkable stability that has allowed life to flourish on our planet for billions of years. Every sunrise is, in a sense, a small miracle of stellar physics that makes everything else possible. The next time you feel the warmth of sunlight on your face, remember that you're experiencing the output of a massive nuclear fusion reactor that has been burning steadily for longer than Earth has existed. And maybe, just maybe, appreciate the remarkable fact that it continues to shine with such consistency that we can build our entire civilization around the assumption that it will continue to do so. But also remember that assumptions, no matter how reasonable, are still just assumptions. The universe is under no obligation to behave according to our expectations, and that's both terrifying and wonderful. The mystery of what would happen if the sun dimmed by half overnight isn't just about stellar physics or climate science. It's about who we are as humans, how we adapt to change, and how we find meaning and hope in the face of the unknown. And that, perhaps, is the most fascinating mystery of all. Thanks for joining me on this journey into one of the most unsettling scenarios scientists have quietly contemplated. The idea of our sun suddenly dimming by half overnight forces us to confront just how dependent we are on cosmic forces completely beyond our control. And yet it also reveals the incredible adaptability and resilience of life itself. What do you think would happen in this scenario? Would humanity unite to face this global challenge, or would society collapse under the pressure? How long do you think it would take us to adapt to a world with half the sunlight we're used to? And perhaps most intriguingly, do you think such an event could actually occur? I'd love to hear your thoughts in the comments below. And if you found this exploration as fascinating as I did, make sure to subscribe to Javis Heist and hit that notification bell so you don't miss our next dive into the mysteries that shape our world and challenge our understanding of reality. Until next time, keep looking up at the stars and wondering about the incredible universe we're all traveling through together. Who knows what cosmic mysteries we'll explore next?